Thanks for watching my video today. Let's prove another integral representation for Li to x, okay? Dilogarithm. Then let's prove that Li to x is x time integral from 0 to infinity t upon e to the t minus x dt, okay? Here, let our integral to be I, then is x times integral from 0 to infinity t upon e to the t minus x dt. Now let's put e to the t equal to u, then t is log u, right? Then dt is 1 over u du. When t tends to 0, then u tends to 1, right? This e to the 0 is just 1. And t tends to infinity, u tends to infinity again. Therefore, integral I is x times integral from 1 to infinity. T is nothing but log u, right? Log u upon u minus x, 1 over u du, which is x times integral from 1 to infinity, log u upon this one, multiply u square minus ux du. And this is, we have already proved, right? Anyway, let's try to prove here again. Now put u equal to 1 over y, then du is negative 1 over y square dy. And when u tends to 1, then y tends to 1. And when u tends to infinity, y tends to 0, right? Therefore, I is equal to x times integral from 1 to 0 log 1 over y square minus x over y, negative 1 over y square dy, which is negative x integral from 0 to 1 log y upon 1 minus xy dy. And using this one you can see, okay? Then is negative x integral from 0 to 1 log y sum from k equal to 0 to infinity xy whole k dy, using the geometric progression of 1 over 1 minus x, okay? Then I is equal to negative sum from k equal to 0 to infinity x to the k plus 1 integral from 0 to 1 y to the k log y dy, which is using IBP. I is negative sum from k equal to 0 to infinity x to the k plus 1 log y to the k plus 1 upon k plus 1 from 0 to 1 minus integral from 0 to 1 over y to the k plus 1 upon k plus 1 dy, which is I is equal to sum from k equal to 0 to infinity x to the k plus 1 upon k plus 1 integral from 0 to 1 y to the k dy, which is sum from k equal to 0 to infinity x to the k plus 1 upon k plus 1 integration of this y to the k plus 1 upon k plus 1 from 0 to 1, right? So I is sum from k equal to 0 to infinity x to the k plus 1 upon k plus 1 whole square 1 minus 0, right? Sum from then is equal to sum from k equal to 0 to infinity x to the k plus 1 upon k plus 1 whole square. This is same as sum from k equal to 1 to infinity x to the k upon k square, which is, and this series, okay? This series is what we call or dilogarithm Li to x, okay? Therefore, Li to x is equal to x times integral from 0 to infinity t upon e to the t minus x dt, okay? So this will be the proof for this integral